Alright, so this video is going to be some more supplementary Newton's laws example problems. Certainly the previous video with examples, we discussed basically the three primary Newton's law problems you can have. You can have an object on a nice flat horizontal table. You can have an object on a nice flat vertical surface, or you can have an object sitting on an inclined plane or a ramp. And what we found is no matter the circumstance, at the end of the day, you ask a series of questions. First, what are the major directions for this system? So that is X and Y, or parallel and perpendicular, or whatever other directions might in this world occur. For us, it's either going to be X and Y directions, which holds for the horizontal surface or the vertical surface, or when an object's on a ramp, then you're looking at parallel and perpendicular. Second question, are there any forces which are not already pointing in these directions? So, for instance, if you have a horizontal surface, you look, okay, X and Y direction are the major directions. All the forces, are there any forces which do not already point in the X or Y direction? If you have a force that's, gravity, gravity's a Y direction. If you're pulling on the box horizontally to the right, that's an X direction. If you're pushing on the box, but it's pushing at an angle, now you have a force which is not already in the primary direction. If you do have any forces which are not already in a primary direction, you break these forces into their components. So you have a horizontal table, a block has a force pointing at 30 degrees, break that force into X and Y components. That's what this means. Then when all of that's done, the third question says, in which direction will the object move? So, take the horizontal table with the object having forces pushing in the X and Y directions and all of that. Which way will the object move? Well, if it's a horizontal table, obviously the object has to move in the X direction. It's not going to move up and down through the table. It has to move horizontally. If we're on a ramp, then no matter what the forces are doing, the object has to slide in the direction parallel to the surface. So once you know what direction the object will move, use the sum of the forces equals mass times acceleration in that direction. Those are the major steps. Now, for each one of these, there may be things you have to do. You have to actually break things into components, so you have to know how to do that, sines and cosines. Using F equals ma, you actually have to plug the numbers in and solve the equation. But if you were going to explain the process, this is what you would do. Given the system, first read the question and see what's the major directions that are important here. Are they the x and y directions or the parallel and perpendicular ones? Given you now know that, look at all the forces. Are there any forces that are not already in those directions? If there are no forces that are not in that direction, that is to say, all the forces are in those directions, then step 2 is done. However, if there are some forces which do not already line up in the major directions, that's when you do your components. Either x and y components or parallel and perpendicular components. And finally, part 3 is, now that everything is set up, you have all the information available to you, do F equals ma, but you do it in the direction that you know the object will move. So, for instance, if it's an x and y direction system, well, it's either going to move in x or it's going to move in y. So if you know which one it is, do F equals ma in that direction. All right. So let's actually do some examples. So the first big example I want to do is a ramp problem again, because I've found over the years that this type of problem is usually the most confusing. So here's a ramp. Ramp is inclined at 30 degrees, and you have a block sitting on the ramp. Mass of the block is 10. There are some forces on this block. Let's say I'm pushing up the ramp like this. This force, obviously, the way the arrow is pointing, is parallel to the surface. So it's not horizontal, it's not vertical, it's parallel. Let's say I push with a force of 50 newtons that way. Question says, find the acceleration of the block. Okay. Well, before I can do that, first let me go ahead and see what are all the forces in my system. Because there may be times where, the question might just be wording, so I want to draw my picture. Or even if there is a picture, there may be some force that's in the problem, but isn't shown in the picture. And indeed, in this case, there is one. Gravity is in this problem. Gravity is always acting, and gravity, when it acts, always acts straight down vertically. So there's mg. All right, so there are my forces. I've got an applied force, which is the yellow one, and I've got gravity, which is the green one. Okay. So, first step of solving this problem. What is the major directions, or what are the major directions important to the system? Well, for this system, I'm on a ramp. Ramp means parallel and perpendicular are my big directions. Okay, so that's step 1 done. Step 2, are there any forces drawn on this picture, or given in a problem, which are not already parallel or perpendicular? Well, note the yellow force. That force is already parallel to the surface. So I already know the applied force has a parallel piece, and it'll have a perpendicular piece. And what do I know? The parallel piece is 50. It's all pointed in the parallel direction, so the whole thing is the parallel component. Of course, also, that means how much of that force points perpendicular? None of it. It's just like saying, I'm pushing on this box horizontally to the right. How much of that force is in the x direction? The whole force. How much of that force is in the y direction? None of it, because it's pointing horizontally. None of it is vertical. Here, the yellow force is pointing parallel, so none of it points perpendicular, so 0. Now what about my green? The green force, mg, call it the force due to gravity, That's a y force. That force is not already parallel or perpendicular. So, step 2 says, go ahead and create a parallel and perpendicular component for this force. So, for gravity, I need a parallel piece and a perpendicular piece. Now, after you've done these problems enough, you could just do this by looking at it and knowing, but of course, we're just learning this for the first time, so I'm going to go ahead and draw the picture again so we can see clearly how to do it. If this is mg, I need to make a triangle out of this force. One side of the triangle has to be perpendicular to the surface. Remember, the surface looks something like this. You know, our box is on top of that gray line. So one side has to be perpendicular to that surface. The other side has to be parallel to that surface. This side over here is parallel. This side is perpendicular. Next thing I know is that the angle of incline of my ramp, the 30-degree angle, is always the same as this angle up here. So that angle is the same as that angle there on my ramp. Once I have my triangle drawn, I can do the components. I want the parallel component of mg. The parallel side is the side opposite to my angle of 30 from my green triangle. So, opposite goes with sine. M, whoops, let me do it in blue. M times G times sine 30. So what's M? 10. G, 9.8. Sine 30. And if you have a calculator, you plug this in your calculator, you get 49. Now, I'm going to have to, that's the calculation. The second part of the calculation is this a positive force or is this a negative force? Well, we have to be very careful for this problem. Notice my applied force, the yellow force, was pointing up and to the right. And so when I wrote down the components, I said the applied force parallel piece is positive 50. Well, that means from the beginning, I'm assuming that this parallel direction, up and to the right, is positive. The perpendicular direction, I'm going to assume, into the ramp will be positive. Again, this is an arbitrary choice. You can pick them oppositely. If you want to pick down and to the left to be the positive direction for parallel, go ahead. What that means then is your applied force parallel wouldn't be positive 50, it would be negative 50, because it's going the other way. But given that I've chosen my directions the way I have, the red things, I know my force due to gravity in a parallel direction is pulling me down and to the left, but I made up and to the right the positive direction, so this guy better be negative. Okay. So again, the component was easy. I took my green triangle. The parallel side is opposite, so I use sine. I get my number, 49. But then, is that 49 positive or is it negative? I have chosen for this problem to make sliding up the ramp to be the positive direction. So my applied force of 50 is up the ramp, he's positive. But gravity is pulling me down the ramp, so he's negative. That's my own choice here. All right, what about the perpendicular piece? Well, the perpendicular side is the side adjacent to the angle, so that's cosine. M times G times cosine 30. So 98 cosine 30 gives me 84.9. Now his direction, positive or negative, well, it's not going to, come into play since we're looking in the parallel direction to answer. But if we're going to be technical, for the perpendicular direction, I chose into the plane, into the floor to be the positive direction. and gravity is pulling me into the floor, so this is positive. Again, that was a choice. You could have chosen the opposite way. Now that that's done, notice all the forces in my problem are now parallel and perpendicular directions. Now I can move on to step 3. Step 3 is, which direction will my block move? Is it parallel or is it perpendicular? Well, obviously my block's going to slide parallel to the surface, so I know I'm going to look in the parallel direction. What's the equation? The sum of the forces equals mass times acceleration. So what are all of my parallel forces? I've got a positive 50 and I have a negative 49. Those are all the parallel forces here, set equal to mass times acceleration. So 50 minus 49, that's 1, equals 10 times A. So A is 1 over 10, which is 0.1. So there we go. Inclined plane problem, multiple forces. What are the steps? First, make sure you understand what are all the forces. Gravity has to be included. What's the major direction for the system? Parallel and perpendicular, because I'm on a ramp. For every force, make sure you have a parallel and a perpendicular component. Well, my applied force was already parallel, so that was fine. Gravity, however, was a y force. It's vertical. So I had to convert the y force of gravity into parallel and perpendicular components. I drew my little triangle here on the right, this green triangle, to help me figure out, am I going to use sine or cosine for the parallel and perpendicular piece? If you want to draw it on the system itself, then of course it would look like this. So here's the perpendicular side, there's the parallel side. All right, let's try a second example. Slightly more complicated than that one. Here's a ramp. Ramp is inclined at 30 degrees. There's a block whose mass is 10. What do we have? Well, there's one applied force, which points to the right horizontally. That force is a force of, let's say, 100 newtons. Call him F1. And then there's another force, F2, of 20. And he points down the plane, down and to the left. For this problem, find the acceleration. Okay. So very similar to this problem. The difference being, in this one, there's two applied forces. The first one is being applied straight to the right, horizontally. The second one is being applied down and to the left along the plane, parallel. All right, so first thing to do is make sure our picture has every force that's required. Well, obviously we're missing a force, and that's gravity. So there's mg. All right, there's no other external force that I know of. I'm not using friction yet. So I can move to step 1. Step 1 says, what's the major direction that's important? Well, we're on a ramp, so major directions, parallel and perpendicular. Next, for every force, you need a parallel and perpendicular component. So that means for F1, I better have a parallel and a perpendicular. For F2, parallel and perpendicular. And for gravity, parallel and perpendicular. All right, so let's go through. F1, is that already parallel or perpendicular? No, it's not. Actually, it points in the x direction. That's bad. So let me make a triangle, which would give me a parallel side and a perpendicular side. Well, I've already got the hypotenuse. That's the 100. That's already drawn. So let me draw another line which is parallel to the surface. There he is. That's parallel. And then let me finish my triangle with a perpendicular line, perpendicular to the surface. And there's our triangle. So this side's perpendicular, this side's parallel. Now I need an angle. Well, as I said, instead of, trying to force it onto you, I'll just tell you. This angle here is the same as that angle there. Okay. So the little skinny angle on the right is the 30-degree angle of the ramp. It's the same angle. Well, now that I have my triangle, let's do components. F1 has a parallel piece. The parallel side is the side adjacent to the angle, and adjacent means cosine. So we've got 100 cosine 30. So it's going to be 86.6. Is this positive or is this negative? Well, I need to choose. I need to choose two directions. A parallel direction, which is positive, and a perpendicular direction, which is positive. Usually what I like to do is I like to make whichever way the block will move, that will be my positive direction. That way when I get an answer, the answer is positive. Now here, it's not clear which way will be the direction of motion. I look at the block. I have some trying to move me down and some trying to move me up. I don't know which one's going to win. So since I don't know, I'm just going to take a guess. I'm going to choose one, and if it comes out negative, it's negative, and who cares? It's not a big deal. So what am I going to choose? I'm making the choice to make down the plane. That will be my positive direction. Okay, so it's the opposite of our last example. In our last example, I made up the plane to be positive. Here, I'm making down the plane to be positive. It really doesn't matter. You have a choice. All right, what about the perpendicular direction? I'm going to make the direction perpendicular, which points down into the floor. That will be my positive direction for perpendicular. Instead of up off the floor, down into the floor. Again, my own choice. It doesn't matter. But once I've made my choice, now let's look at this. My F1 parallel. Which way does it move the box? Well, F1 is pushing straight to the right, so the box is going to want to move up the plane because of him. Well, I made down the plane positive, so up the plane then must be negative. So this force better be negative. So I put a negative on him. And there we go. There's the parallel component of F1 done. What about the perpendicular? Well, same thing. Look at my yellow triangle. The perpendicular side is the side opposite to the triangle, to the angle of 30. Opposite means sine, so 100 sine 30, which is 50. Now, is he positive or is he negative? Well, you're going to find it doesn't matter here, but if I'm going to be correct, if I push on this block straight to the right, does that make the box want to go into the floor or pull up off the floor? Well, obviously, if I'm pushing the block straight to the right, it's trying to make the block go into the floor. For my perpendicular direction, I made into the floor positive. So this is positive. So positive 50 is fine. So F1 taken care of, completely finished. Now let's look at F2. F2 is a force which pushes down the plane. That means he's already in the parallel direction. So The parallel piece of F2 is 20, the full thing. Is he positive or is he negative? Well, F2 pushes down the plane. I made down the plane positive, so in this case, he's positive. What about the perpendicular piece of F2? Well, if F2 is pointing in the parallel direction, that means none of them points in the perpendicular direction, so the perpendicular piece is just 0. So now F2 is done. And now we got gravity, the green one. Well, gravity is pointing in the y direction. He's a vertical force. This is bad. I need a parallel and perpendicular piece. So I made my triangle. Gravity is already there. That's the hypotenuse, straight down. I need a side which is perpendicular, and I need a side which is parallel. Parallel here, perpendicular here. There's the angle up top. It's kind of small, but it's the same one we've done for the other examples. All right, so gravity, let's look at the parallel piece. A parallel piece is that side which is adjacent to the angle, and adjacent we know goes with cosine. So it's m times g times cosine 30. Okay, m for this problem is 10, g 9.8 as always, cosine 30. And we get 84.9. Is this positive or is this negative? All right, let's think. Gravity, what will it do? It's pulling down. So that makes my block want to move down the plane. Looking at what I chose down the plane to be the positive direction. Gravity makes my block go down the plane, the positive direction. So this force is positive. So good. I don't have to put a negative on him. He's done. Perpendicular piece. Oh, my Lord, I made a mistake. I do apologize. This should be sine 30. I hope you caught it when I was doing this. Because if you did, that means you really do understand this very well. You're not just listening to me ramble. The parallel piece is that side which is opposite to the angle. If you look at the green triangle. Opposite goes with sine, not cosine. So this should be sine 30. So that should be 50. The perpendicular piece is the piece which is adjacent. Looking at my green triangle. Adjacent is cosine, so it should be mg cosine 30. So 10 times 9.8 cosine 30. And that's my 84.9. Is he positive or is he negative? Well, let's see. Gravity pulls down on the block. So in the perpendicular direction, that means it's trying to make the block go down into the floor. My choice of positive direction for perpendicular was down into the floor as positive. So this is a positive force. All right, so the hardest part of the problem is now over with. We took all the forces in my problem, broke them all up into parallel and perpendicular components. Some of the forces, F2, were already in the parallel or perpendicular direction, and the other ones were not. So the ones that are already parallel, that's easy. You write it down. But the ones that are in the x or y direction, that's the ones you have to break into components. And again, now you're seeing why we spent so long at the beginning worried about can we do components, because this is what's happening. But we work our way through it little by little. We get all of our answers listed out. Now that we have them listed, we can finally go to the last piece of the problem, which is which direction will my block move? I know it's either parallel or perpendicular from the very first step. But now I look at the forces, I say, well, the block is on the ramp. The only thing the block can do is slide along the ramp, which means it must be in the parallel direction. So looking in the parallel direction, I use the equation F equals ma. What are all my parallel forces? Well, I have them listed. I've got a negative 86.6 plus a positive 20 plus a positive 50. So plug all this in my calculator, and I believe you get negative 16.6. That's the forces. Let me go ahead and write it on a second line, just so I'm not confusing on what I'm doing. I like to do it like this. So we had negative 86.6 plus 20 plus 50. That's F's. Those are all the forces, equals mass, 10, times acceleration, A. Negative 86.6 plus 70 is negative 16.6, equals 10 times A. Thus, A is negative 1.66. I got a negative answer. Is this okay, or does that mean I did something wrong? Both. It's wrong only in the sense of when I originally chose my directions, which way should be positive, I chose the wrong direction to be positive. At least wrong in the sense of if I want a positive answer at the end, I chose it wrong because I got a negative answer. But it doesn't matter, because what we do as physicists is we say, okay, the acceleration is negative 1.66. What does that mean? It doesn't mean slowing down or whatever. What it means is the acceleration is 1.66 and it points in the negative direction. So what's the negative direction? Well, look at my choice in red. I chose down the plane to be positive, so the negative direction must be up the plane. So the fact that I got an acceleration of negative 1.66, all that means is it's 1.66 up the plane. That is to say, my F1 force is big enough to slide the block up, even though those other forces are trying to bring me down. So it's perfectly fine to get a negative answer. If you, when working this problem yourself, had chosen up the plane to be the positive direction, then your final answer would have been positive 1.66, the same answer I got. Okay, so first thing to note is if you're looking at solutions and you're comparing your answer to mine or your answer to someone online or whatever, if the answers are the same but there's a sign difference, if you look at how the problem was set up, likely what happened was you chose a direction to be positive, the other person chose that direction to be the negative direction. But that's okay. As a physicist, you have complete control over which directions you make positive and negative. You're allowed to do that, and no one can say it's wrong. What's key is how I did it in this picture is I let everybody know from the picture which direction I'm choosing to be the positive direction. That way, when someone looks at my answer, they say negative 1.66, what does that mean? They look at my picture and say, oh, he chose downward positive, so this means this thing's going upwards. Okay, that makes sense. Another thing to note, this is pretty much as complicated as it's going to get. Okay? So if you think this is, fairly complex beast of a problem, that's perfectly fine because it's not getting worse than this. At least not until we do friction. When we do friction, you're going to have the same problem, but with one extra force called friction. So in that sense, it's going to be, one step more complicated. But as I said in the other video, when we deal with friction, it really doesn't make things all that much harder. It just puts one more step in the process. So that means if you can sit down with a blank sheet of paper, given this question, and you could write out the solution and understand the steps you're doing, then you're able to solve the most complicated problem I can give you on the test. If you can't do that yet, that's fine, you're just learning it. But you should practice these problems over and over and over again. And don't just practice it to memorize the numbers and memorize, okay, this goes here. Do it and understand, why did I use cosine here? Why is this one negative instead of positive? Don't just memorize this step, he wrote this, so I'm going to write this. That's very, very bad. I want you to, if you want to, kind of remember the words I'm talking about as I'm solving the problem, to help you remember what the steps are, that's fine. But I want you to think your way through this problem. Understand, why am I listing these forces like this? Why did I choose parallel and perpendicular? How do I know the perpendicular piece of gravity uses cosine instead of sine? You have to be able to get to the point of solving these problems enough to where if someone asked you that question, you could tell them. You could speak it logically and say, oh, well, that's because if you look at the force due to gravity and you make the right triangle, the perpendicular side of that triangle is adjacent to the angle. And adjacent goes with cosine. That's why it's cosine. The answer is not, well, that's because the teacher, when he wrote it down, he used cosine. I'm flattered that you think my answers are always going to be perfect, but as you saw in the middle of this problem, I made a mistake. And that can happen along the way. So you need to be able to look at what I'm doing and be critical and say, do I think it should be cosine? Or, I don't know. He said it's sine, but I don't think it should be sine. And think your way through it. And if you think you're right, email me. Tell me, oh, look, in the example problem number 2, you were doing the work, and I noticed you use sine here, but I think it should be cosine. Can you tell me if I'm right or why you think it should be this? And, it could be that I did something wrong. But if I didn't do something wrong, then at least I can explain it to you. That way you won't make a similar mistake if you're the one who made the mistake on a test. I want everybody to be able to sit down with their test paper and a blank sheet of paper, get this problem, and work the steps out logically, get the right answer, box it up, and be happy that you were able to do it without anyone's help. So anyway, I wanted to give these extra example problems because, as I said, these are going to be as complicated as they get. They're really not that much more complicated than the other examples we've done. It's just it has extra steps. It's got extra forces. There are more forces here that you had to break into components than the previous video. But if you notice, the major steps were the same. Figure out what the directions are, break everything up into components, use F equals ma in the correct direction. So anyway, hope this was helpful. As I said, feel free to email me if you have any questions. Work on these practice problems a bunch. Homework will be due fairly soon, of course. And test is coming up fairly soon as well. Once we finish friction, then the first test will be here. And as I said, we'll talk about test review and stuff then. But basically, kinematics and Newton's laws, that's what your first test is on. So make sure you understand this very, very well, because it's going to be a major part of your first test. Until next time.